Carl Zeiss is a German manufacturer of optical systems, industrial measurements and medical devices, founded in Jena, Germany in 1846 by optician Carl Zeiss. Together with Ernst, Abbe and Otto Schott, they built a base for modern optics and manufacturing. There are currently two parts of the company: Carl Zeiss AG located in Oberkochen with important subsidiaries in Aalen, Göttingen and Munich, and Carl Zeiss GmbH located in Jena. Carl Zeiss AG is the premier company of the Zeiss Gruppe, one of the two large divisions of the Carl-Zeiss-Stiftung. The Zeiss Gruppe is located in Heidenheim and Jena. Also controlled by the Carl-Zeiss-Stiftung are the glass manufacturers Schott AG and Jenaer Glas, located in Mainz and Jena respectively. Carl Zeiss is one of the oldest existing optics manufacturers in the world. Corporate history. Carl Zeiss opened an optics workshop in Jena in 1846. By 1847 he was making microscopes full-time. By 1861 Zeiss was considered to be among the best scientific instrument makers in Germany, with about 20 people working under him, with his business still growing. By 1866 the Zeiss workshop sold their 1000th microscope. In 1872 physicist Ernst Abbe joined Zeiss and along with Otto Schott designed greatly improved lenses for the optical instruments they were producing. After Carl Zeiss's death in 1888, the business was incorporated as the Carl-Zeiss-Stiftung in 1889. By World War I, Zeiss was the world's largest location of camera production. Zeiss icon represented a significant part of the production along with dozens of other brands and factories, and also had major works at Dresden. In 1928 Hensoldt AG was acquired by Carl Zeiss and has produced the Zeiss binoculars and rifle scopes since 1964, occasionally resulting in twin products being offered under both the Hensoldt and Zeiss brand names. The Hensoldt System Technology division was continued by Zeiss under the Hensoldt name until 2006. As part of Nazi Germany's Zwangsarbeiter program, Zeiss used forced labor during the Second World War. The destruction of the war caused many companies to divide into smaller sub-companies and others to merge. There was great respect for the engineering innovation that came out of Dresden. Before the war, the world's first 35mm single-lens reflex camera, the Koenig Schachter, and the first miniature camera with good picture quality were developed there. At the end of the war, Jena was occupied by the U.S. Army. When Jena and Dresden were incorporated into the Soviet occupation zone, later East Germany, some parts of Zeiss Jena were relocated by the U.S. Army to the Contessa manufacturing facility in Stuttgart, West Germany, while the remainder of Zeiss Jena was re-established by the German Democratic Republic as Kombinat VEB Zeiss Jena. As part of the World War II reparations, the Soviet Army took most of the existing Zeiss factories and tooling back to the Soviet Union as the Kiev Camera Works. The Western business was restarted in Oberkochen as Optisch Werke Oberkochen GmbH in 1946, which became Zeiss Optisch Werke Oberkochen GmbH in 1947, but was soon renamed to Carl Zeiss. West German Zeiss products were labeled Opton for sale in the Eastern Bloc, while East German Zeiss products were labeled Zeiss Jena for sale in Western countries. In 1973, the Western Carl Zeiss AG entered into a licensing agreement with the Japanese camera company Yashica to produce a series of high-quality 35mm film cameras and lenses bearing the Contax and Zeiss brand names. This collaboration continued under Yashica's successor, Kyocera, until the latter ceased all camera production in 2005. Zeiss later produced lenses for the space industry and, more recently, has again produced high-quality 35mm camera lenses. The Eastern Zeiss Jena was also well known for producing high-quality products. Following German reunification, VEB Zeiss Jenaer reckoned as one of the few East German firms that was even potentially able to compete on a global basis. Became Zeiss Jena GmbH, which became Jenoptik Carl Zeiss Jena GmbH in 1990. In 1991, Jenoptik Carl Zeiss Jena was split in two, with Carl Zeiss AG taking over the company's divisions for microscopy and other precision optics and moving its microscopy and planetarium divisions back to Jena. Jenoptik GmbH was split off as a specialty company in the areas of photonics, optoelectronics, and mechatronics. The Zeiss AG was renamed Carl Zeiss Sports Optics GmbH on October 1, 2006. The companies of the Zeiss Gruppe in and around Dresden have branched into new technologies, screens and products for the automotive industry, for example. Today, there are arguably three companies with primarily Zeiss icon heritage: Zeiss Germany, the Finnish-Swedish icon, and the independent Eastern Zeiss icon. On June 28, 2013, Carl Zeiss officially announced its plan to rename the brand from Carl Zeiss to simply Zeiss. All the products will be standardized under the Zeiss brand. Innovations: the Zeiss company was responsible for many innovations in optical design and engineering. Early on, Carl Zeiss realized that he needed a competent scientist so as to take the firm beyond just being another optical workshop. In 1866, the service of Dr. Ernst Abbe was enlisted. From then on, novel products appeared in rapid succession which brought the Zeiss company to the forefront of optical technology. Abbe was instrumental in the development of the famous Jenaer optical glass. When he was trying to eliminate astigmatism from microscopes, he realized that the range of optical glasses available was insufficient. After some calculations, he realized that performance of optical instruments would dramatically improve if optical glasses of appropriate properties were available. His challenge to glass manufacturers was finally answered by Dr. Otto Schott, who established the famous glass works at Jena, from which new types of optical glass began to appear from 1888 to be employed by Zeiss and other makers. The new Jena optical glass also opened up the possibility of increased performance of photographic lenses. The first use of Jena glass in a photographic lens was by Voigtler-Karantzin, but as the lens was an old design, its performance was not greatly improved. Subsequently, the new glasses would demonstrate their value in correcting astigmatism, and in the production of apochromatic lenses. Abbe started the design of a photographic lens of symmetrical design with 5 elements, but went no further. Zeiss' domination of photographic lens innovation was due to Dr. Paul Rudolph. In 1890, Rudolph designed an asymmetrical lens with a cemented group at each side of the diaphragm, appropriately named anastigmat. This lens was made in 3 series, Series 3, 4 and B, with maximum apertures of f/7.2, f/12.5, and f/18 respectively. In 1891, Series I, 2 and I appeared with respective maximum apertures of f/4.5, f/6.3, and f/9, and in 1893 came Series IA of f/8 maximum aperture. These lenses are now better known by the trademark Prota, which was first used in 1900. At the time, single combination lenses, which occupy one side of the diaphragm only, were still popular. Rudolph designed one with 3 cemented elements in 1893, with the option of fitting 2 of them together in a lens barrel as a compound lens, but it was found to be the same as the Dagger by C.P. Goetz, designed by Emil von Hu. Rudolph then came up with a single combination with 4 cemented elements, which can be considered as having all the elements of the Prota stuck together in one piece. Marketed in 1894, it was called the Protalent Series 7, the most highly corrected single combination lens with maximum apertures between f/11 and f/12.5, depending on its focal length. But the important thing about this Protalens is that 2 of these lens units can be mounted in the same lens barrel to form a compound lens of even greater performance and larger aperture, between f/6.3 and f/7.7. In this configuration it was called the Double Prota Series VIA. An immense range of focal lengths can thus be obtained by the various combination of Protalens units. Rudolph also investigated the double Gauss concept of a symmetrical design with thin positive Manisho enclosing negative elements. The result was the planar series IA of 1896, with maximum apertures up to f/3.5, one of the fastest lenses of its time. Whilst it was very sharp, it suffered from coma which limited its popularity. However, further developments of this configuration made it the design of choice for high-speed lenses of standard coverage. Probably inspired by the stigmatic lenses designed by Hugh Aldous for Dornier of London, Rudolph designed a new asymmetrical lens with 4 thin elements, the Unna series IB, with apertures up to f/4.5. Due to its high speed, it was used extensively on hand cameras. The most important Zeiss lens by Rudolph was the Tessar, first sold in 1902 in its series IB f/6.3 form. It can be said as a combination of the front half of the Unna with the rear half of the Proter. This proved to be a most valuable and flexible design, with tremendous development potential. Its maximum aperture was increased to f/4.7 in 1917, and reached f/2.7 in 1930. It is probable that every lens manufacturer has produced lenses of the Tessar configurations. Rudolph left Zeiss after the First World War, but many other competent designers such as Merter Copyright, Wondersalb, etc. kept the firm at the leading edge of photographic lens innovations. One of the most significant designer was the ex-Journeyman man Dr. Ludwig Bertel, famed for his Ernst high-speed lens. With the advent of the Contax by Zeiss Icon, the first serious challenge to the Leica in the field of professional 35mm cameras, both Zeiss Icon and Carl Zeiss decided to beat the Leica in every possible way. Bertel's Sonne series of lenses designed for the Contax were the match in every respect for the Leica for at least 2 decades. Other lenses for the Contax included the Biota, Bargain, Orthometer, and various Tessars and Triotars. The last important Zeiss innovation before the Second World War was the technique of applying anti-reflective coating to lens surfaces invented by Alexander Smakula in 1935. A lens so treated was marked with a red T, short for transparent. The technique of applying multiple layers of coating was developed from this basis after the war, and known as CHOR. After the partitioning of Germany, a new Carl Zeiss optical company was established in Oberkochen, while the original Zeiss firm in Jena continued to operate. At first both firms produced very similar lines of products, and extensively cooperated in product sharing, but they drifted apart as time progressed. Jena's new direction was to concentrate on developing lenses for 35mm single-lens reflex cameras, and many achievements were made, especially in ultra-wide-angle designs. In addition to that, Oberkochen also worked on designing lenses for the 35mm single-lens reflex camera Contorex, for the medium-format camera Hasselblad, for large-format cameras like the Linhof Technica, interchangeable front element lenses such as for the 35mm single-lens reflex Contarflex and other types of cameras. Since the beginning of Zeiss as a photographic lens manufacturer, it has had a licensing program which allows other manufacturers to produce its lenses. Over the years its licensees included Voigtler Currency der, Bausch & Lomb, Ross, Co-Ristka, Kraus, Kodak, etc. In the 1970s, the Western operation of Zeiss Icon got together with Yashica to produce the new Contax cameras, and many of the Zeiss lenses for this camera, among others, were produced by Yashica's optical arm, Tomica. As Yashica's owner Kyocera ended camera production in 2006, and Yashica lenses were then made by Cosina, who also manufactured most of the new Zeiss designs for the new Zeiss Icon coupled rangefinder camera. Another licensee active today is Sony, who uses the Zeiss name on lenses on its video and digital still cameras. Business relationships: Zeiss has licensed its name and/or technology to various other companies, including Hasselblad, Rollei, Yashica, Sony, Logitech, and Alpa. The nature of the collaboration varies, from co-branding optics designed by another firm to complete optical design and manufacturing. On April 27, 2005, the company announced a collaboration with Nokia in the camera phone market. Cameras to emerge from this collaboration included the Nokia N90, Nokia N8 and Nokia 808 PureView. Zeiss Icon cameras: Zeiss Icon is the primary brand name for cameras made by Carl Zeiss. Cameras bearing this name have included the Zeiss Icon Icoflex twin-lens reflex and Zeiss Icon Contarflex single-lens reflex cameras, the Zeiss Icon Netta medium-format folding camera, the Zeiss Icon Contina 35mm folding camera, and 2 distinct families of rangefinder cameras which are both called simply Zeiss Icon. The most recent Zeiss Icon rangefinder camera was an M-mount camera with automatic exposure, introduced by Zeiss in 2004, manufactured in Japan by Cosina, and now discontinued. Camera lenses Cinema lenses Carl Zeiss AG has long been renowned for its motion picture lenses. Zeiss manufactures prime and zoom lenses for 35mm, 16mm, and 65mm film production. They also make lenses for digital cinema and high-definition video. Zeiss is mainly known in the trade for their association with the German camera manufacturer Abbe, for whom they currently produce lenses. Current models of Zeiss cinema lenses are medium format lenses Carl Zeiss AG has produced lenses for Hasselblad and Rollei cameras, including a complete list of Zeiss Hasselblad lenses, including datasheets, is available from Hasselblad Historical. Large format lenses Zeiss has produced lenses for large format and press cameras, including Zeiss has departed the large format optics field along with Nikon, leaving Schneider and Rode in stock as the primary makers of such lenses today. ZM lenses Zeiss ZM lenses fit Leica M-mount cameras, including Leica M series, the Ricoh GXR-A12, and many mirrorless interchangeable lens cameras through the use of adapters. Some ZM lenses are manufactured in Germany by Zeiss, others in Japan by Cosina. Lenses designated C are considered compact or classic lenses. Zeiss claims that the 25mm E/2.8 ZM achieves a resolution of 400 lpm in the center of the image at E/4, which is equal to the calculated diffraction limit for this aperture. Z-series SLR lenses Zeiss produces optically identical manual focus lenses for multiple SLR lens mounts under the ZE, ZF, ZK, and ZS lines, manufactured in Japan by Cosina to Zeiss specifications. ZF series lenses fit the Nikon F mount. 4 design variations are designated ZF, ZF2, ZFI, and ZFIR. All are manual focus designs with Nikon AIS-type aperture indexing. ZF lenses have AIS aperture indexing, half-stop aperture ring detents, and no electronic features. ZF2 lenses are like ZF lenses, with the addition CPU functionality, similar to Nikon AIP lenses. They allow electronic focus confirmation, full metering compatibility, and electronic aperture control with Nikon SLR cameras which require CPU lenses. ZFI lenses feature mechanical locks for focus and aperture, and additional environmental sealing, for industrial applications. ZFIR lenses are adapted to infrared imaging, with coatings that transmit wavelengths up to 1100 nanometers, and focus scales marked for infrared. ZE lenses fit the Canon EF mount. They feature electronic contacts allowing for focus confirmation, and electric aperture operation as with standard Canon EF lenses. ZK lenses fit the Pentax K mount. They have no electronics, are manual focus only, Ka couplers. Zeiss announced in September 2010 the discontinuation of the ZK line. ZS lenses fit the M42 lens mount. By use of mount adapters they can be adapted to most 35mm bayonet camera mounts including Canon FD and EF, Pentax K, Minolta SA and Sony Konica Minolta A mounts, usually losing open aperture metering, multi-segment metering, focus confirmation, automatic flash zoom capabilities as well as some built-in shake reduction performance and EXIF data accuracy. Otis lenses Zeiss produces manual focus Otis lenses for the Nikon F mount and Canon EF mount, with electronic features equivalent to Zeiss ZF2 and ZE lenses respectively. Otis lenses are complex no-compromise designs which Zeiss refers to as the best in the world in the normal lens and short telephoto categories. They cover the 35mm format. Otis Apu Distagon T28mm E/1.4, Otis Apu Distagon Chaw 55mm E/1.4, Otis Apu Planar Chaw 85mm E/1.4. Otis lenses Zeiss produces autofocus Batis lenses for the Sony E-mount. Like Sony FE lenses, they cover the 35mm format. Zeiss Batis 2/25, Zeiss Batis 1.8/85. Loxia lenses Zeiss produces manual focus Loxia lenses for the Sony E-mount. Like Sony FE lenses, they cover the 35mm format. Loxia Barganshaw 35mm E/2.0, Loxia Planature 50mm E/2.0, Loxia Distagon T21mm f/2.8. Tote lenses Zeiss produces autofocus tote lenses for the Fujifilm X-mount and Sony E-mount. They cover the APS-C format. Tote Distagon 12mm E/2.8, Tote Planature 32mm E/1.8, Tote Macro Planature 50mm E/2.8. Milvus lenses Zeiss produces manual focus Milvus lenses for the Nikon F-mount and Canon EF mount, covering the 35mm format. Milvus Distagon 21mm E/2.8, Milvus Distagon 35mm E/2, Milvus Distagon 50mm E/1.4, Milvus Macro Planature 50mm E/2, Milvus Planature 85mm E/1.4, Milvus Macro Planature 100mm E/2. Super rotator lenses These are 360° tilt shift lenses for 35mm format including full-frame digital. Available mounts, Canon EF, Nikon F, Sony Alpha Konica Minolta A mount. Other mounts on request. Manual focus only, no electronics. Manufactured in Germany and Ukraine. Hartblei Super Rotator Carl Zeiss Distagon IF1, 4.0 40mm, Hartblei Super Rotator Carl Zeiss Planature 1, 2.8 80mm, Hartblei Super Rotator Carl Zeiss Macro Planature 1, 4.0 120mm. NASA Zeiss is currently in the process of designing the optical components for the James Webb Space Telescope set to replace the Hubble Space Telescope sometime in 2018. A unique triplet of ultra-fast 50mm f/0.7 lenses originally created by Zeiss for NASA's lunar program had the distinction of being reused by Stanley Kubrick in the filming of his historical drama Barry Lyndon. The period atmosphere of the film demanded that several indoor scenes be filmed by candlelight. To facilitate this, Kubrick had the lenses modified to mount onto a cinema camera and two of them subsequently further modified in separate ways to give wider angles of view. Smartphone lenses Nokia 808 PureView features a lens custom developed by Zeiss for its 1/1.2-inch sensor. As did its successor, the Nokia Lumia 1020. ZA lenses ZA lenses are designed and manufactured by Sony in Japan, and co-branded with the Zeiss name. Sony and Zeiss collaboratively set design and quality parameters for ZA lenses. A-mount ZA lenses fit the Sony Alpha Konica Minolta A mount. They are fully dedicated autofocus lenses with 8 electrical contacts, ROM-IC, and distance encoder function to support ADI flash. All except for the DT lens are full-frame lenses. Sony I+/- Carl Zeiss Distagon 1 to 24mm ZA-SSM, Sony I+/- Carl Zeiss Planature 1, 1.4 50mm ZA-SSM, Sony I+/- Carl Zeiss Planature 1, 1.4 85mm ZA, Sony I+/- Carl Zeiss Sonature 1, 1.8 135mm ZA, Sony I+/- Carl Zeiss Vario Sonature 1, 2.8 16 35mm ZA-SSM, Sony I+/- Carl Zeiss Vario Sonature 1, 2.8 24 70mm ZA-SSM, Sony I+/- Carl Zeiss Vario Sonature DT1, 3.5-1, 4.5 16 80mm ZA. E-mount ZA lenses are fully dedicated Sony E-mount autofocus lenses. Lenses carrying the E designation cover the APS-C format, while lenses designated FE cover 35 mm format. Sony I plus or minus Carl Zeiss Sonnetror E1, 1.8 24 mm, Sony I plus or minus Carl Zeiss Sonnetror FE1, 2.8 35 mm ZA, Sony I plus or minus Carl Zeiss Sonnetror FE1, 1.8 55 mm ZA, Sony I plus or minus Carl Zeiss Vario de Satur FE1 416 Euro 35 mm ZAOSS, Sony I plus or minus Carl Zeiss Vario de Satur FE1 424 Euro 70 mm ZAOSS, Sony I plus or minus Carl Zeiss Vario de Satur E1 416 Euro 70 mm ZAOSS. In addition to these Sony collaboration lenses, Zeiss offers Tote, Loxia and Batis lenses for E-mount. Other products. Zeiss and its subsidiaries offer a wide range of products related to optics and vision. These include camera and scene lenses, microscopes and microscopy software, binoculars and spotting scopes, eyeglasses and lenses, planetariums and dome video systems, optics for military applications, optical sensors, industrial metrology systems and ophthalmology products. Even video glasses belong to the product range. In the summer of 2012, the new video glasses Cinemizer OLED will come on the market. In addition to the viewing of 2D and 3D movies, it will be possible to play PC games when it is fitted with equipment. The largest part of Carl Zeiss AG's revenue is generated by its semiconductor manufacturing technologies division, which produces lithographic systems for the semiconductor industry as well as process control solutions. Sports optics Carl Zeiss Sports Optics division produces rifle scopes, spotting scopes, binoculars, and distance measuring devices for outdoors enthusiasts. The two main product lines are the Conquest line, which is manufactured in Germany and assembled in the United States, and Victory line, which is produced entirely in Germany. Zeiss Sports Optics are revered among the best in the world, and are utilized by military and law enforcement agencies in countries around the world. Medical Solutions This branch of Carl Zeiss is managed by Carl Zeiss Medic. It is divided in ophthalmology, optometry, neurosurgery, ENT, spine, P&R, dentistry, radiotherapy and gynecology. Vision Care Carl Zeiss Vision Care division develops, manufactures and distributes ophthalmic lenses, lens coatings, and dispensary technologies and services. Zeiss is known for ophthalmic lenses made from high refractive index glass, allowing stronger prescription lenses to be thinner. Their progressive lens ZEISS Progressive Individual has won multiple awards including the OLA Awards in 2009 presented at Washington, D.C. and the Vision Plus or VP Awards in 2014 at Mumbai, India. Industrial metrology Zeiss Industrial Metrology specializes in high-accuracy measurement systems, including coordinate measuring machines, computed tomography measurement machines, optical measuring equipment, metrology software and measurement sensor systems. The Industrial Metrology subsidiary provides this equipment to a wide range of manufacturing facilities worldwide. Zeiss has manufactured coordinate measuring machines since 1919, offering very basic manually operated CMMs. In 1973, Zeiss introduced the UMM 500, using a Zeiss sensor system and Hewlett-Packard computer. Zeiss has since vastly improved and diversified their product line and now feature many high-accuracy CMMs, the Metrotom, a CT X-ray scanning measuring machine, with the ability to quickly and completely measure a part in 3 dimensions without ever touching the part, and the O-Inspect, a fully optical measurement machine. Zeiss is currently a member of the International Association of CMM Manufacturers. Many of the sensor systems produced by Zeiss are proprietary technologies, using technologies exclusively patented by Zeiss, and therefore can offer better accuracy and repeatability than its competitors. Zeiss was the first manufacturer of coordinate measurement machines to introduce computer numerical control technology to a coordinate measurement machine. Zeiss was the first company to offer CNC stylus changer capability for the said machines. Lithography Carl Zeiss Summit lenses are used in chip lithography machines for focusing the extremely short wavelengths. Microscopes Zeiss offers different types of microscopes: optical microscopes, laser scanning microscopes, scanning electron microscopes, scanning helium-ion microscopes. Fire doors The name Zeiss icon can also be found in old cinemas, on fire shutters on the projection windows. These had heat fuses that melted and dropped the shutter over the hole if the film caught fire in the projection booth. See also, telescopic sight, Walther Bauersfeld, Zeiss projector. References. External links, official website, Zeiss Company timeline starting 1973, Carl Zeiss Company timeline starting 1909.